This program is brought to you by Stanford University. Please visit us at stanford.edu.
This presentation is delivered by the Stanford Center for Professional Development, providing graduate-level education to working professionals, online, on campus, and on-site. For more information, please visit study.stanford.edu.
This week we have Ron Baecker from the University of Toronto, from a group there which I love the fact that the name got all the right buzzwords in it. It's the Knowledge Media Design Institute. And it's about all those things, about knowledge and media and design. I have to say this, because we both have enough gray hair. I can remember when I was a graduate student, which was a few years ago, that I was at an AI lab, and pretty much everything that people there thought was interesting was work in artificial intelligence, except there was this one cool thing that this guy did on animation. And it was the first sort of thing that was actually making things move around on a screen in an interesting way that was done by computer. And that was Ron's early work on animation, which he has followed up by a lot of work on graphics, animation. A lot of you know one of the key readings books on graphics is by Bill Buxton and Ron. He's started a couple companies. He's been at Toronto for a number of years and done interesting things across the board in knowledge, media, and design. And he'll be talking about that today.
Okay, thank you, Terry. It's really a pleasure and an honor to be here. I'm not sure this was the best time to do the talk after 5 or 6 days of the Chi conference, but I certainly appreciate those of you who are here, and I guess I have no idea who's watching me remotely, but that actually relates to one of the things I'm going to talk about briefly. So I'm going to be very self-indulgent today, and you're going to have to bear with me. I turned 65 in October, and that has gotten me to sort of look backwards a little bit and think forwards a little bit. And so what I'm going to do is, in the first 15 minutes, review 40 years worth of work in one area, and then talk about another line of research that I started about 5 years ago. And I'm rather optimistically thinking that, well, let's set an ambitious goal. Let's say 40 years for that as well. That would take me to age 99. So let's see how we do. So about a dozen years ago, we wanted to bring people from various disciplines at the University of Toronto together in what has proved to be primarily a teaching program, a collaborative program. In a way, it's like very similar to the D School, except perhaps not as interesting. We decided that we needed a term to describe it. And we thought about digital media, we thought about new media, and we basically came up with the phrase knowledge media. It had been used in a slightly different context in the AI community somewhat previously, but about the time that we created the Knowledge Media Design Institute, Mark Eisenstadt at the Open University created the Knowledge Media Institute. So what are knowledge media? Well, one of the first persons to think some of these thoughts was Vannevar Bush with his MEMX idea. I was more influenced as I was in my PhD program by a paper by JCR Licklider in which he talked about the notion of coupling computers and human thought processes to enable new levels of thought. So when we created our institute, we talked about systems or technology to aid thinking, creativity, learning, communications, and collaboration. It doesn't have to be digital to be a knowledge media, but we're primarily interested in digital knowledge media. And this slide shows some of examples of things that are knowledge media. And in the class I teach on knowledge media fundamental concepts, we sometimes spend some time asking what's not a knowledge media. So it's fairly broad. My favorite example here in this area is a digital cadaver. By the way, so how many of you are primarily from computer science? How many of you primarily from product design, education, Roy P., medicine, bioengineering, anything else? Art, graphic design, industrial design? Okay. So what I'm going to do in the talk then is talk about knowledge media for multimedia communications, focusing on sort of 7 pieces of work that I and my students and collaborators have done over the 40 years. In most cases, I'm just going to give you a snippet, starting with, in fact, the PhD work that Terry so kindly referred to. I have one slide about lessons learned, and then I'm going to talk about this other area of research dealing with knowledge media to aid human cognition. So this is a little snippet from my PhD work.
We don't have to draw each individual frame. Instead, we can show Genesis how to move a ball by drawing the desired bounce. Lynn has told Genesis to combine the sketch of the ball with the sketch of a bounce to create a bouncing ball. Let's look at this technique called the P-curve more closely. Lynn sketches an alternative motion for the ball, which it then carries out. Genesis records not only the path, but the dynamics with which her hand traces it out, and to help her, displays the movement as she draws it. Any movement that can be mimicked can be constructed in this way: bounces or leaps or spirals, zigzags and swishes and zooms. It takes only seconds to try out a new idea. Hence, animation becomes immediate and spontaneous.
So this was, this P-curve that I developed was really one of the first uses of gestural interaction, and I believe was somewhat influential in influencing some of the development of Bill Buxton's thinking in his early days when he came to the University of Toronto in 1975. I came out to Palo Alto, the only time I've spent a significant amount of time here in, well, actually I was once more at Apple, but I came out in '74 to, together with Tom Horsley and again animator and animation teacher Eric Martin, to see what one could do in terms of interactive animation in Smalltalk. And this has no sound, but I'll just show a little clip of it. So this is Smalltalk in those days. It was it hadn't moved as much towards an environment for software engineering that it turned into later. But we were able to very, very rapidly build a tiny little animation system called Shazam. This was, I guess, in Smalltalk 72, perhaps the first real implementation of Smalltalk. It was just a wonderfully rich and flexible and powerful programming environment. And what was neat here was that you can see 2 windows, one of which on the right you're sketching E-frames or images, and on the left you're actually seeing animation. So what's actually going on here is the animator, I assume this was Eric Martin, whose hand we're seeing here, was actually advancing the movie to a particular frame and then saying, okay, I'm going to now create another image that can be used in the animation, and you'll see that happen in a second on the right. And what's amazing about this, and of course this was very gratifying to us, because previously we had worked on only very on displays that could just show individual dots of light. You can see here that as you're sketching the this other image, it's immediately introduced into the animation sequence. So, and the ability to do that with literally a few lines of code was very eye-opening to me. And we have not actually, unfortunately, had an environment or done work in an environment that was as powerful and as rich for doing this kind of thing since then. After I got to Toronto, or as I was already in Toronto in '74, I started working and doing experiments over a number of years, applying animation to a very different kind of problem, which was, can you use animation to improve computer science? And you can think about that in 2 ways. Could you enable software engineers to better understand large software? And we've done a little of that without huge success. But what could you do for for teaching. And this is...
Sorting is the process of rearranging items so that they are in order. Personnel records may be sorted.
This is a movie that I completed in 1981.
Hockey players may be ordered by lifetime goals scored. This film presents and compares
it shows nine different sorting
techniques or algorithms: 3 insertion sorts, 3 exchange sorts, and 3 selection sorts. Our first 3 techniques are called insertion sorts. Each one works by inserting new items into data that is already in order. The simplest insertion sort is called linear insertion.
Each title sequence is in fact animated using the technique. And the music is not directly driven by the animation. It was done by a composer in the spirit of the animation, using some of Bill Buxton's sound synthesis, early sound synthesis.
The linear insertion sort compares the first 2 items to see which is smaller and discovers that they are already in order. The third item is larger than the second and in its correct position relative to the other 2. The fourth item is not. Thus we find the correct position and insert it into place.
Okay, so now...
Why not see the whole film again?
This is a 12 times speeded up version of the entire movie, just to give you a feeling for the pedagogy. So you're seeing what we just saw. That's linear insertion, then binary insertion, and now shell sort, which is this amazing collection of linear insertions across subsequences. And now you see stats that give you a feeling for complexity. And now you see a race of 250 data items. And now we go into exchange sorts. You see bubble sort, shaker sort, which is sort of a clever bubble sort going both ways, and quick sort. And again, if we weren't doing it 12 times speeded up, if you heard the sound, you would actually understand what's going on. And this is the race. You can see quick sort. And so then the challenge was, stop. Okay. The challenge was how at the end would I compare 9 different algorithms.
So that everything will fit, we represent each item with a dot, its position by its horizontal coordinate, its value by its vertical coordinate. Thus, unsorted data appears as a cloud, sorted data as a diagonal line.
So now the difference between n log n sorts and n squared sorts really becomes very visual. And so this was when, and of course we didn't have real-time equipment to do this instantaneously. We had to plot this on microfilm recorders in those days and wait a couple days to see the result. But when we saw the result, we were really very pleased with the way this worked out. So this helped inspire a fellow named Mark Brown at Brown to do a very important PhD thesis on algorithm animation, which sort of looked systematically at the issues of how do you build tools to do that. We had not done that. A little later on, the graphic designer Aaron Marcus and I turned our attention to source code visualization, in particular with the C language, and you see the before and after image there, and I don't have time to go into the details. And then when I came back to Silicon Valley in '89, together with Ian Small and once again Eric Martin, we worked on another use of animation, this for animated icons. So this is work we did at Apple. And I think this was shown at Chi 91. And so I'm just going to show you the first one of this. This is, we did animations of the entire HyperCard painting icon palette. And you see here an animation of the line tool where in a little bit of animation in about 20 seconds, in space no bigger than this, you really get a sense of some of the capabilities of what you can do with the line tool. And we actually reported at Chi 91 an experiment that demonstrated that this was superior to just looking at the static icons. The last area of work in the visual communications area that I'm going to talk about, I've then moved away from just looking at animation to looking at digital video. And in some sense, that was made possible as technology got better. Our first attempt at that was a system that started as a master's thesis by Alan Rosenthal and led to an ill-fated company called Expresto Software. My first company, HCR, was much more successful and was eventually sold to the Santa Cruz operation before SEO became a four-letter word. And this, I'll just show you this on the left, which was just an attempt to explain what MAD, which became Expresto Creator, was doing.
Expresto Creator is an all-in-one tool that enables you to build and export desktop video. With its simple interface and intuitive design, you can start using video without any previous experience. Scripts are written directly into our unique script editor, or cut and paste from a word processor. Videos are structured using our system of acts, scenes, and shots. Images are added with a click of a mouse, and graphic elements are added simply and quickly with our title and graphic.
Technology requires support.
Creators' built-in video capabilities allow you to digitize and edit live video.
Expresto is support that...
Okay, sorry, I clicked on the other one by mistake. I'm not going to show you the right-hand video. The company failed in great part because companies like Apple and Microsoft started giving video software away for free, even though conceptually wasn't there. What was interesting about this approach was that it didn't view video as a linear sequence. It viewed video as hierarchically structured documents, and that's one of the reasons we called it a word processor for movies or a word processor for video. And ultimately, we tried to apply it to video for explaining complex technology and sell it to the CRM marketplace, but as several things in my career, it was ahead of its time and it failed. The last project along this line, which we believe will be successful, and I would encourage some of you to come up and get these beautiful bookmarks afterwards, is a recent project that takes the same idea of hierarchically structured video documents, but doesn't try to build a complete authoring tool from scratch. It takes the approach that there's a large variety of structured video documents that can be created as captures of lectures and presentations. For example, this talk, I'm not sure what software is being used to beam me out to the world and who's looking, who's watching, et cetera, hi out there if you're watching. I wish I knew who you were. So we started a new project at Toronto in around 2000 called ePresence. In part, it was we took the name in part because Bill Buxton had a very amazing project in the early 90s called Telepresence, and we wanted to sort of pay homage to that. But unlike Bill's desktop video conferencing approach, we said we're really interested in large scalability, and so instead of working on video conferencing, we worked on using streaming media and webcasting. And so we've built a system that allows you to capture a talk such as mine, PowerPoint slides, video, screen captures, allows a certain amount of interactivity. I assume that the people who are watching me on whatever technology is being used cannot ask questions. Or they can't ask questions? No. Yeah, okay. So we have text questions to the speaker, moderated chat, private messaging. We currently support voice questions in a very rudimentary fashion. But most interestingly, the technology is highly scalable, cross-platform, and open source. And it builds archives that are very, very rich. They're structured in that it uses the same idea that MAD did of hierarchically structured documents. You can use that structure to navigate using a two-level table of contents or a timeline. You can search any text that appears in the PowerPoint slides or in the metadata. We're working on the ability to search the voice track, and it's taggable and embeddable. I don't have time to explain that. So here are a few screen snaps. On the upper left is an ePresence event that we did recently in Malaga, where we were bridging using video conferencing technology to link Mikhail Gorbachev sitting in Moscow to Malaga, and then capturing that with ePresence and broadcasting that worldwide. In the lower right, you see an interesting use in an educational sense, in which we've been using, we have a very interesting course now called Communication Skills for Computer Scientists that involves writing, public speaking, and interpersonal communications. And you see a student here doing one of our public speaking exercises, and the TA is actually bookmarking and making notes in real time on her presentation, and then that feeds into a persistent chat system which allows them to continue a discussion about what she was doing right or what she was doing wrong. And this is based in part on a very interesting master's thesis by David Fono on persistent chat, which was reported at CSCW 2006. This is an image from the 4.0 release that's going to happen this summer, in which we're putting more emphasis on the notion that we now have, we suspect, thousands of hours of rich media that various ePresence adopters have built, have captured all over the world, mostly in universities and medical schools. And so we're trying to, very much in a YouTube-style fashion, but not just with video, short videos, but with long video documents that have interesting structure and that have synchronized PowerPoint slides and other things, make that accessible. So you see here a talk that Vinton Cerf gave in Toronto a few months ago, and you can see over here the hierarchical structure, the so-called chapters and the slides. You can't see the timeline very well there, but it enables you to go through and find what you want. And this is a quick shot of what the new Rich Media portal is going to look like this summer. The last thing that I'll mention about this project that I think is very interesting is, and maybe at that point I'll encourage a couple questions about this, because then I'm going to be sort of focusing in on the other theme, is that it occurred to us that even while we're webcasting to the many, and which could be dozens or hundreds or in principle even thousands depending on the server technology you're using, that for every 100 people who watch, maybe 10 might like to participate in some way, and hopefully only 1 or 2 are doing it at once. And so what we've done is bridge conferencing and webcasting. In this video submitted with an unsuccessful Chi submission.
This video presents a novel extension to the ePresence webcasting system developed based on our studies of presenter behavior in classroom situations. Video conferencing supports symmetrical multimedia communications at a distance among small numbers of individuals by high bandwidth connections. Webcasting uses multimedia streaming for a one-to-many transmission from a speaker to large numbers of participants over high and low speed connections. In webcasts, the amount of interaction with remote viewers is typically very limited. Video conferencing offers a much higher level of interactivity, but is constrained by high bandwidth requirements and poor scalability. Let's see how some of the advantages of video conferencing can be brought to ePresence, an open source webcasting infrastructure. To accomplish this, we use a remote viewing interface to increase the ability of remote participants to interact naturally in real time, and an in-room awareness display, which makes remote participants more visible to the speaker and local audience. Let's watch as a remote participant requests permission to speak. Colors allow the speaker and local audience to quickly identify those participants who are speaking or want to speak. Here, the participant is requesting permission to speak and is bordered red. The moderator grants the participant permission to speak, and he joins into a live voice conversation with the speaker and local audience. When he is speaking, a chat bubble appears over his in-room display representation. Also, questions, comments, and discussion can be sent to other remote participants and the local in-room display using a chat window. Interaction is more natural and easier for the speaker than text chat would be in webcasts without our system, and research is ongoing to bridge the interactivity gap.
Yeah. So this last image is an image from a class I ran in the fall. I ran my Business of Software class using this prototype technology, bridging. Originally was supposed to be 3 Toronto campuses. It turned out to just be 2. But also the conferencing interface, which of course you can do just at any desktop with just a headset and a webcam, allowed me for the first time. I've been teaching this course for roughly 20 years since coming back from my first startup. For the first time, I wasn't limited to entrepreneurs that I could find in Toronto, and there are quite a few in Toronto, but I had my second cousin, who's a very brilliant software entrepreneur in Pasadena, California, talking from his home, and a fellow who used to work for me, who's a major Korean software entrepreneur, talking from his desktop in Seoul, Korea. So what have we learned from all this? I mean, I've been thinking about this over sort of the past week. I mean, one thing we've learned is that we really have to understand each of these, although these are all tools for visual communications, they differ very dramatically depending upon the task, the stakeholders, the work practices, the workflow, et cetera. So when we originally developed MAD, we thought maybe it might be of interest to professional filmmakers, but in fact it wasn't, because professional filmmakers have a very structured way of working, certain job responsibilities, unions, et cetera, and it just was no interest. So it was a tool that was designed for an individual filmmaker. Extensibility and tailorability is key, and we haven't been able to achieve that yet in the cognitive aid area, but we really need it because, as Elliot Cole, one of the pioneers in technology for cognitive assistance, has argued eloquently, almost everyone who has some sort of cognitive impairment or cognitive disability is very different, and you really need to be able to tailor things. The role of collaboration in media creation consumption is something that has been very important. And finally, what's been interesting over the 40 years is that, as Eric Martin taught me when I got into this 40 years ago, timing is absolutely key. And I remember Eric looking at the few dots that you could put on the TX2 screen and saying, don't worry about it. You can do amazing animation with just a few dots as long as your timing is correct. And now, even 40 years later, as we have almost no limits in the visual complexity of what we can put up on the screen, this is still important. So before I go on and shift gears, and there is one point of connection between these two lines of research, and I'll get to that in about 10 minutes, I'd be happy to take a question or two if anyone has one. Yeah?
I'm just wondering, will you be speaking more about the problem of timing?
No.
Could you elaborate then a little more? I'd enjoy hearing a little more about how you perceive the problem and the issue.
Let's see. Let me quote Eric, the famous Canadian animator Norman McLaren, if I can remember the quote exactly, which is, animation is not about what appears in the frames, but what appears in the interstices between the frames. And so the whole idea of visual communications is to artfully and creatively construct a sequence of images, a sequence of sounds, a sequence of sound effects or music that is engaging, that is communicative, that has the appropriate interconnections between sound and image, et cetera, et cetera. So for example, there's been one of the area that I showed you a little bit about, the area of software visualization. There have been some studies, and I won't mention who did the studies, but they're fairly well-known people, in which they built animations of computer programs, and they did some experiments and showed that they didn't help students comprehend. And I remember looking at one of those animations and realizing, well, no wonder. The animation just wasn't designed carefully enough in terms of controlling the flow of images and the timing and the pacing to communicate. part of it is also the ability to interact, the ability to stop, go back, et cetera, which wasn't something that was that easy in the early days, but now is a piece of cake. So I'm not sure that answers your question, but that.
No, I
yeah.
just thought it was a very interesting one.
Yeah. Okay, so so about 5 years ago, I said it's time to start doing something else, and the area that I thought was worth doing was technology for cognitive assistance, and there were a number of reasons. First of all, the number of people with cognitive impairments is growing dramatically. You see at the bottom of this slide some of the data from the United Nations that basically says that in 2001, 1 out of every 10 persons was over 60. By 2050, it'll be 1 out of every 5. And by 2150, if the world lasts till then, it'll be 1 out of every 3. There was an article in the Globe and Mail recently entitled Rock of Ages that remarked that I think it was the Rolling Stones had been known recently to play one song several times or twice in a concert because they forgot that they had played it earlier. I recently had the privilege of listening to Arlo Guthrie and some of his children and one of his grandchildren give a concert on the Florida Keys. And Arlo Guthrie, at least 8 times in an hour and a half, made an insecure remark about memory issues, et cetera, et cetera. So this is something, and the Alzheimer's disease projections are rather staggering. At the moment, it's 4.5 million in the U.S., projected to triple in the next 40, 45 years. Yet there's more and more technology that you would think be relevant, ranging from cell phones. This was a 2005 data point. By now, it's well over 1 billion, or it's 1.5 billion. The now renamed $150 laptop, the fact that storage costs essentially nothing, various advances in multimedia, computer vision, et cetera. And so when the computer was developed, the phrase, the memory of the computer, was adopted by analogy with human beings. And it seems to me it's about time that we start to turn it around and think about the use of computer memory, computer processing to aid human memory, or more generally human cognition. There are, of course, many kinds of non-electronic cognitive aids. You see here 2 of my favorites, Post-its in the upper right and a pill dispenser in the middle right. It, of course, doesn't have to be technology. It can be the artful location of technology. So, for example, many people use the place they place something in the direction that they oriented as a way to remember, like have they taken their pills or not. And, of course, humans are one of our most important memory aids. The pill dispenser that you see there is not my current one. It's the last one I had. And you notice that I was able to use it even though 2 of the 8 modules were defective. How many programs do we write that still will run if 2 of the 8 modules are defective? And so we really have a lot of work to do if we're going to make our technology equally effective. There are, of course, lots of electronic devices around. I quite loved the original slogan when the Trio came out for, I guess at that point it was called Handspring, Talk, Organize, Connect. And another technology that's coming along very rapidly is the technology of knowing where things are. This mentions GPS tracking, but of course there are a variety of other technologies that allow you to track both indoors and outdoors. And so in thinking about cognitive aids over the last 5 years, and this was not obvious to me when we started, one can imagine 3 different kinds of goals in increasing degrees of sophistication. Number 1 is a prosthetic device, something that compensates for the loss. So if you have difficulties in remembering to take your medications, is there something that will help you and remind you appropriately? The more ambitious goal is a rehabilitative or a restorative goal. Can you restore some function that is decayed? or been impaired in some way. And the last goal, the most speculative and the most controversial, but in a sense the most exciting, is it possible to delay the onset of some cognitive impairment or cognitive decline? So I'm going to describe two projects that we've actually done some, I believe, significant work on. The first is a project of participatory design for and with people with amnesia. And we work with a kind of amnesia called Anterograde amnesia, which is the difficulty in storing new memories. And this can happen through brain injury, through certain kinds of viruses. One of the teenagers in Brian Richards' practice got hit by a golf ball on the head. I'm a little more careful now on the golf course about where I stand. And our clinical collaborator in this is a wonderful man named Brian Richards, who in the last 15 years of work with a patient population of people with anterograde amnesia started out about 12 years ago building physical memory books, which consisted of loose-leaf notebooks with a bank of switches. And it was possible to train people with amnesia. Their ability to learn procedural skills is intact. It just takes a lot of work. And their communications abilities are intact. To train them to every night write down the appointments on page 1 of their notebook, set the switches. So, for example, at 9 o'clock the next morning a switch would go off. They would want to turn the switch off because the alarm was annoying. Open up the book, read, okay, I'm supposed to walk the dog. Turn the switch off, close the book, and then at 10:30 they would be reminded to take their medication or whatever. About 6 years ago, Brian started to work with Palm Pilots, and of course there are many kinds of examples of technology for reminding that people have been working with. One of the most widely deployed is a paging system called NeuroPage, which I believe was built somewhere maybe in the Valley. I don't Hirsch and Treadgold, I think, are the names. I don't know the individuals, and that's at least deployed in the UK. So a new master's thesis of mine came along about 4 years ago, Mike Wu, and we set the master's problem for him to see what he could do in designing some technology that was relevant to the needs of some of Brian Richards' population. And we chose to do this rather than sort of a classical user-centered design approach. We decided to do it as a participatory design process because we really felt that we had no idea what it was like to have amnesia. And so we couldn't, I mean, I'm a knowledge media designer. You've seen examples. Even though I can't draw worth a damn, I know what it is to draw and I can understand that. But in this area, I just couldn't conceive of it. So Mike started out that, and because he was designing with his design partners, we didn't know what he was going to design at the beginning. And he started with some brainstorming sessions with a team of 6 people with amnesia, himself and Brian Richards, a clinical psychologist. And of course, it became apparent very quickly that we had a great challenge because the amnesics would not remember from one week to the next what they had discussed the last week. Now, and sometimes in design sessions that can be a blessing, but Mike had to overcome that, and over the course of about 6 months, he developed a series of techniques which have been reported both at CHI and the Participatory Design Conference of being highly structured in approaching design, in documenting design history. Mike, in fact, is a very good note taker, and he would take notes for each meeting and then beam it from his palm to everybody else's palm for them to go home so they could review it before the meeting, and doing things that are very reminiscent of many participatory design processes, including a lot of use of physical artifacts, post-it, storyboards, etc., and was able to, in fact, decide together with his team that the two things they were most concerned about, one was losing their palm. If you have amnesia and you lose your palm, it's not like what happens with us. It's like a piece of your brain has come out. And so this has happened to two of the 6 individuals in the design team, and they were devastated for months. We didn't know how to turn that into a computer science master's thesis. But the other thing they were concerned about was orientation. And by orientation, I don't mean like the kind of orientation problems I have, like I walked over with Terry from Sweet Hall to here, and I was, you know, I think we were going north or something, but you know, I have a map and et cetera. But orientation, like you're somewhere and you have no idea why you're there or who you're with if they've stepped off or et cetera. And so what Mike designed together with his design partner is what a relatively simple piece of software. The lower right shows how you would record a meeting and its purpose with a typical Palm interface, and on the upper right is what Mike and his team designed, and he did some evaluations which were relatively preliminary but quite positive. The most important part, though, about Mike's thesis is that he showed that you could work together with a population of individuals with severe cognitive impairments and do participatory design. And the phrase participatory design is used very sloppily a lot of places. I mean, there are number of people who work with people with cognitive disabilities that claim they're doing participatory design, and they're really not. They're just designing for one client. And in this case, Mike had an entire team, and so in theory, the generalizability of what he did would be a little better. What Mike's doing now, and maybe once he finishes, maybe you'll invite him down to give a talk, because I think it's going to be a beautiful PhD thesis, is that he observed, and I speculated that what's happening if you have amnesia is that you're not just combating the amnesia by yourself, you and your prosthesis. It's you and your family members and your caregivers that are combating it. And so Mike's PhD thesis looks at memory aids as collaboration technology. He spent about 100 hours shadowing the 10 people with amnesia, or 120 hours, and their family, is analyzing this using grounding theory, and is now in a participatory design process again with 6 Amnesics and himself and Brian Richards, but also this time having parallel design teams with the Amnesics and another design team with caregivers, and basically looking at the design of information management software for the home of Amnesics that deals primarily with communication, coordination, and scheduling issues in the home. I'm going to talk to you about one other project and then just mention 2 other projects that are on the drawing boards and then take questions. The other project, and this does relate back to the major line of my work, is deals with multimedia biographies for people with Alzheimer's disease. As you probably know, Alzheimer's disease impacts memory, impacts executive function, and often results in phenomenon where someone who has Alzheimer's disease can no longer recognize or name loved ones, and not only is there Alzheimer's disease, but over the last 10 years, the clinicians in this area has decided that there is something that's called mild cognitive impairment, in which on things like the mini mental status exam and things, you're not scoring as badly as with Alzheimer's, but it's often a disease that's on the road to Alzheimer's. So if you're diagnosed with MCI, the odds are better than 50% that within 4 years you'll be diagnosed with Alzheimer's disease. And so so that's the need. Can you help people with Alzheimer's disease reminisce about the past and be better able to recognize and remember people who are important in their life? Once again, it seemed that the technology was right to start working on this problem. There's huge amount of interest now in family history, genealogy websites. Gordon Bell up the road, I don't know exactly where he works, is his own guinea pig, trying to digitize absolutely everything about his life with the My Life Bits project. Microsoft Research Cambridge has this lovely device called SenseCam, which captures an entire day of what one might call visual episodic memory of what happened in a day, and has some very encouraging preliminary results about the effects of this in stimulating memories. And there was a very interesting paper about this by Abby Sellen at CHI earlier this week. And so Tara Cohane, a master's student of mine who started about the same time as Mike, built a system or a methodology to build interactive multimedia biographies of individuals with Alzheimer's disease. And the idea was to help them and their families reminisce about the past, and this to be primarily compensatory, a prosthetic, but possibly restorative. We started out initially, we were funded by the Alzheimer's Association to just work with people with Alzheimer's disease, but in fact, as the research progressed, we decided to work with people with mild cognitive impairment as well. Tara developed the methodology for organizing the raw materials for the biography, and once again, it made use to some extent of this notion that comes out of my earlier work of thinking of video not as a linear stream, but as a hierarchically structured document. So we were thinking about your biography as a set of scenes within an act, within a set of acts, where an act might be adolescence, university days, your first marriage, your second marriage, I don't want to be too cynical, etc. And the multimedia is produced, we used, because of the realities of some of the people who are our clients, we decided not to deliver this via the internet, which was our initial goal, but to deliver it via DVD, which is either linear or has branch points that you can decide to go ahead within an act or not. So we've been working very closely here with, again, it's now called just Baycrest, was the Baycrest Center for Geriatric Care in Toronto. We've had over 24 referrals of individuals with Alzheimer's and to some extent with MCI. Of this, we've been working with 14 families or individuals. 2 of the cases, in one case, one individual died. In another case, there was a problem with the caregiver. But by the end of this grant, which will wind up this fall, we will have completed a dozen multimedia biographies, 6 for individuals with Alzheimer's and 6 for mild cognitive impairment. And what's been very gratifying and was one of the goals of the project was we didn't want to use professional film crews. I mean, we've had 8 multimedia biographers along the line. None of them, well, one was the son of a filmmaker, so he had some prior experience, but all the rest are computer scientists, social workers, architects, et cetera, et cetera. This is, I'll show you a brief clip of a woman with Alzheimer's disease watching her multimedia biography, or a piece of it.
Lovely, right?
Yes. Yeah.
She's using a little
That's beautiful,
mouse that Tira sewed into the fabric so she could hold it in her hands. Not a mouse, a trackball.
I lived there.
Yeah, you did.
This woman had been moved by her children from Cape Town 3 years previously. Okay, so we're just completing a number of the biographies, and we suspect that by the time we've completed our analysis, which includes 3-month and 6-month follow-up interviews with the family members, or in the case of MCI, with the individuals themselves, the instructions are they're supposed to watch the biography either once or twice a week, and we're having diary records, and we'll do qualitative analysis of the interviews and of shots of the individuals watching the biographies, that in general this seems to bring enjoyment, helps preserve a sense of identity. We don't quite know how to define that, but it seems to be there. Enhances memory. You saw a bit of that in this clip. Stimulates conversation among family members, is very satisfying and important to the family members in various ways, including being better able to accept the disease. And also in this case, in one other case where an individual is living in a long-term care facility, the caregivers, the paid professional caregivers, watch this and suddenly have some idea, okay, this is not just another lady with Alzheimer's, but this is this particular individual. In looking at these two projects, we then wanted to say, what's common about this? How do we, what else can we do in this area? And so we developed a research framework, and I'm going to go quickly. I'm going to skip over some of the rest of the material because I really want to allow enough time for questions and discussion. But basically, again, stimulated in part by my experience with the earlier area, we thought, well, we have to come up with a systematic way of understanding these different projects. And so dimension one is what kind of cognitive process are we dealing with? And you've seen two examples here, one orienting, one reminiscing. Number two is the distinction I mentioned previously of prosthetic versus rehab versus preventative. What condition are we dealing with? Are we dealing with amnesia or possibly normally aging? Who's actually the user? This is the issue that Mike Wu has been struggling with. We're not just designing for the person with the cognitive impairment, but often for caregivers as well. What technology and what design approach? And so where are we going for here? Well, one project that we're looking for money for and are very hopeful is something that a lot of studies have indicated is very important for senior citizens, is name recall. You see there some data from a couple studies that were done in the early 90s in which a variety of senior citizens basically said the ability to remember names is the thing I'm most concerned about. I had a senior's moment at Chi when I ran into a student of mine who's now working, well, she wasn't my student, but I was the one, she worked for me and I got her into the graduate program. She worked for Mark Chignall, and I was trying to introduce her at Chi and I couldn't remember her name. And so once again, there's lots of technology out there that would make you think that you could build something. When you think about it, we have lots of time prostheses around. I'm looking at one back there, but we have very few name prostheses. Steve Mann, you see Steve Mann and his cyborgs on the upper right, has talked for years about wearing a head-mounted display that would do face recognition. To my knowledge, although there have been maybe one or two research prototypes, this is not real. And so what we want to build is a context-aware cell phone to aid in recalling names and recognizing faces that would know, for example, I'll use a Toronto analogy, if I'm at Yonge and Eglinton and it's 7 o'clock on a weekday evening, my cell phone should be able, if it knew enough about my social network, it should be able to say, you're walking east on Eglinton, you may be walking to the Kate Buckman Bridge Studio, you're probably going to play duplicate bridge, and here out of your social network of several hundred people, say, are the people who are the bridge players. So I'll skip over that. The last project that we're, again, looking for funding for, and this goes back to this distinction that I made, can you think about preventing? There's a notion out there, use it or lose it. Can we prevent cognitive decline? Do crossword puzzles, play Sudoku, et cetera, et cetera. This is big business now. There's a company up in San Francisco, Posit Science, that has some very interesting technology for doing this. Nintendo sold 3 million brain age games in its first 3 months. And there's increasing evidence of what we call neuroplasticity, a very interesting book just written called The Brain That Changes Itself, and that basically says that the old notions that by the time you get to my age, you've pretty well had it and it's just downhill after that, is wrong, that you can generate new neurons, that you can teach an old dog new tricks. Yet the evidence is very inconclusive. There's a lot of hype about this. My wife picked this up, and you can't read it, from the Calgary newspaper when she was out there recently teaching what's 9 letters long and can help delay Alzheimer's. Well, not everybody is quite as careless in their advertising as this ad in the Calgary Herald, but it's going to get more and more like this. My colleague, I visited Yakov Stern at Columbia Medical School for 4 months last year. He has a concept called cognitive reserve. And the idea of cognitive reserve is an attempt to explain why you could do brain scans of 2 people and they both seem to have plaques and tangles that are visible in the brain, yet one seems to have Alzheimer's disease and one doesn't. And they argue that there's something called cognitive reserve, which is correlated with the amount of education you've had, the job complexity, how much social interaction you've had, how much physical exercise you've done, and even Nick Scarmea's claims how much you've eaten the Mediterranean diet, that would increase your cognitive reserve. And there are lots of correlational studies that show that people with high cognitive reserve are more resilient to the onset of Alzheimer's disease. And we don't know to what extent this is based on activity over a lifetime, and to what extent we can go in and intervene at age 50 or 60 and say, okay, well, you haven't done a lot of crossword puzzles till now, but get busy and you can slow down the onset of Alzheimer's disease. Although, again, it's sort of one of these catch-22 things. The data does show so far that even if you have higher cognitive reserve and Alzheimer's comes later, it then sets in faster, so you may not live longer, but perhaps you increase your quality of life. So there's lots of controversy. Very eminent cognitive psychologist called Timothy Salthouse, who wrote a very negative article in a major journal about the evidence is not, there's very little sound evidence that says you can intervene late in life. Yet at the end, he says, well, people keep asking me, should I do crossword puzzles or whatever? And he says, well, yeah, if you like it, by all means do it. It probably does no harm. Maybe there'll be better evidence at some point soon. And so go ahead and do it. So we're very much struck, Yakov and I have been very much struck by the increase of gaming, the fact that senior citizens more and more are getting online. Yet most internet games are not very well suited for senior citizens. They've been very poorly designed. So what we want to do, and again, this is something we're looking for money for. It's very hard to get money for this kind of work, is we want to build a website for cognitive recreation and social stimulation where we can actually do controlled experiments on, let's say you spend 10 or 15 hours a week doing cognitively stimulating activities of one kind or another, with and without social interaction, because I'm convinced that's part of it. And what can you measure in terms of people's results on batteries of psych tests, et cetera, et cetera. And this was our first prototype for a game of Boggle. So what I presented to you is, I guess it was just about an hour, not quite, 2 very rich knowledge media design spaces. And I guess my message, or my bottom line, is that I think this second one, which I personally hope to work on for another 35 years, is I sure hope some of you will be joining me in this activity, because it's a wonderful area for research, both from the field of HCI as well as clinicians, postdocs, graduate students, et cetera. And we need a lot more people working on this. There was a wonderful talk at CHI by Gregory Abad about his work at the other end, developmental disorders, autism. There are lots of interesting similarities and differences between these two domains, but this is not one domain. I mean, amnesia is very different from MCI, is very different from Alzheimer's disease, is very different. I'm personally very interested in multiple sclerosis because my sister has that, and there's lots of work to be done. So thank you very much. And I guess we've got 20 more minutes for me to answer your questions. Yes, David.
What are some of the ways that you evaluate your devices and research?
Okay, well, the let me just we don't. Let me just talk about the multimedia biography one. So what we're doing in the multimedia biography is we're when we finish the biography, we go and basically deliver it to the client. In the case of the MCI individuals, it's usually an autobiography. They're helping to define their own autobiography. In the case of people with Alzheimer's, it's usually a biography, and this is the first time they see it. We go in and we record them watching it, and then and then we ask the caregiver to show it to them once or twice a week, to make a diary records of what's happening while the person's watching it. I guess if we had more money, we would videotape all of this, but we just have diary records. We then go in at 3 months and 6 months, do interviews, watch the individual with AD watching it again, record that on video, do interviews with the caregivers, do it again at 6 months, and then we're trying to do open coding, qualitative analysis of all of that. And there's a huge amount of work, and we don't have enough money to do it as well as we should, but that's what we're doing. This is very challenging in terms of data collection. And again, the work that Gregory Abad and some of his students have done, Jillian Hayes and Julie Keentz, is very important because they've been looking a lot at how do you use ubiquitous computing technologies to help do better data collection, again, in this now at the other end, in the case of kids with autism, which is going to be relevant here. Terry?
Well, just a question about the biographies.
Yeah.
There's a spectrum where on one end you could say, okay, this is something an expert goes in and does with the help of the family or whatever. On the other extreme, you could say, we can provide tools that make it easy enough that it just becomes something you do.
Yeah.
Where on that are you interested?
Well, we're interested in both ends. I did have a master's student who unfortunately went to work and sort of disappeared, who was starting on the tool building, and the approach that we wanted to take was a web environment that made it easier for family members who could be anywhere in the world to at least contribute material, sort of a distributed multimedia scrapbook. At some point then we want to work on authoring tools as well. Mike Massimi, another student working in this area for me, is going to possibly be doing something like this in an internship at MSR Cambridge this summer. So we're really interested in tool building as well. At the moment, it's fairly labor intensive, and we, our multimedia biographers, typically spend 50 to 100, in a couple cases it's gone as high as 150 or 200 hours working with the family members, eliciting the stories, defining what eliciting the raw materials, defining what the story is, structuring it, and actually producing it using sort of off-the-shelf video and multimedia authoring stuff like Final Cut Pro, et cetera, et cetera. So that's a fair investment. What comes out of it is our smallest was 20 minutes, our longest was an hour and 5-minute production. So it is still fairly labor intensive. On the other hand, I think there's a great part of that that'll never go away even with automation. But think about if someone says to you, summarize your life in 30 or 40 minutes. What do you say? That's rather, and in fact, in some cases there are disputes among family members about what's important, what to include. In some cases there are serious emotional issues, like in one case someone had just lost one of his daughters several months before starting, and at first he didn't want to include it, and then as we worked with him several months later, he decided no, he was going to include his daughter. This was important. So this is heavy-duty stuff. There's a parallel project called Circa from the University of Dundee that's trying to use multimedia to stimulate reminiscence among people with Alzheimer's disease. They constantly said, we don't want to do personal stuff because it could be traumatic. We're going to do multimedia images about the city of Dundee. Elsa and I, my collaborator Elsa Martielli, who's a social work prof, said, no, we want to go in and we want to do this is a personal record, and we're convinced that this is an important approach to try. So, and this links in a way to the work that MSR Cambridge is doing with the SenseCam, because the SenseCam comes back, you take it around, you wear it for a day, and it's 3 or 4 minute visual episodic memory record of what you did in a day. We produce in some sense, visual episodic AV record of what you did over your lifetime. There's sort of 1,001 difference if you look at the amount of data, and there are issues of what's the role of automatic capture, what's the role of human designed storytelling, how do you combine, mix and match the two. That's very interesting that we've been talking to the people at MSR Cambridge about. Yes?
Yeah, you mentioned that it's the right time for these kind of technologies, and I'm thinking of other technologies that might apply to smart house, for example, intimacy technology over the web where you simply acknowledge another person's presence, the sophistication of robotic pets, for example. What do you think of these other things?
Absolutely. I think I'm personally not that enthused about robotic pets, but just call me a Luddite. But I think some of the awareness technologies to link, for example, remote caregivers and family members to with loved ones who are seniors and are off on their own is very important. One of the things we want to do with the in the Name Face project is not only include what you can do on a cell phone, but what you can do with some of these electronic picture frames. And so I think there are many technologies in the area, and I did not have time in this talk. I mean, perhaps again, it was my self-indulgence. I wanted to talk to you about some of my earlier work. If I hadn't done it, then I could have done more justice to some of the other work in this area. And also, I should say that although my approach is very much comes from HCI and is very much cognitive assistance for cognitive activities like communicating, orienting, reminiscing, etc. There's another school of work, and I have a colleague in occupational sciences, bioengineering, and Toronto Rehab in Toronto named Alex Michaelides, who comes at this as an AI/computer vision person and is doing cognitive assistance for physical activity. So for example, he built smart bathrooms where a computer vision system is watching someone with Alzheimer's disease wash their hands. And I haven't always been the greatest fan of AI, although I love Terry's PhD work. But in this case, if you think about if you're a caregiver with someone with Alzheimer's disease and you have to accompany them into the bathroom 6 or more times a day to make sure that they can wash their hands, if in fact you can get a smart bathroom to watch you, that's a fairly compelling notion, and Alex has very compelling early results with that. And he's also working, for example, on the problem of fall detection, which again he's trying to provide cognitive assistance like a system that asks you are okay and lets you communicate, but he's using smart technology, computer vision, etc., to detect what's happening in a physical action of trying to walk down the stairs safely. And so there are many different approaches in this field that are interesting. So again, lots of work to be done. God, I wish you were using ePresence and I could get questions from the people out there. By the way, please, here's some bookmarks. You should, or go to ePresence.tv. Okay, some other questions? Surely we have another 10 minutes.
Really straight questions. I've been staring at the seal over your head.
Okay.
What is the word in Latin?
Would you believe that I actually don't know? That's embarrassing. It's the University of Toronto seal. I actually don't know what it means. That's highly embarrassing. Anyone here know Latin?
That says something, actually, in terms of modern education.
Yeah. Questions about the earlier part of the work? Questions about HCI? Yes, anything?
I have a question about the earlier part of the work that you decided to skip.
Okay.
I'm interested in visualizing, you said that you did work about visualizing source code.
Okay.
And if you can elaborate on it, because the whole issue of visualizing abstract notion like logic is very interesting to me. So.
Okay, well, I don't think we approached it at that level of abstraction. But our goal, this was a project that Aaron and I dreamed up in the early 80s when we were at a DARPA meeting, I think in Key West or something like that. And I mean, Aaron's a graphic designer and typographer. And I was I had done some work already. I mean, I'd done a lot of work in using animation, but it only seemed to be relevant in those stages to fairly small programs and algorithms. So the question was, what could you do about source code? And if I could, I could go back to that slide. Okay, so this is what source code looked like in those days on the left. Okay, and it looks like just a blur. It's a single font, no use of boldface, no use of italic, no use of highlighting, no use of color, no use of what typographers call rules or lines of various thicknesses, no significant, very little intelligent use of page layout. And so what we built was a hacked up version of the portable C compiler, which we called SEE, that basically transformed the C program on the left to a program on the right. And so I don't have time to go. It's actually, our work is documented in a book called Human Factors in Typography for More Readable Computer Programs, which is available, published by ACM Press / Addison Wesley. And so, so what we did is we used all the tools that typographers and designers have at their disposal to make important information jump out at you and enable you to distinguish different kinds of information. So for example, the most important thing in this piece of source code is the name of the file. And you can immediately see this phone.c. The second most important thing perhaps is the distinction between code and comments. And comments either appear in the left as marginalia or here as on a gray field, so distinguishing it from the code. And there are a variety of other techniques we did. And you notice here that the phone.c is called Chapter 1, very much in the spirit of what Knuth was doing with literate programming. We thought of a piece of source code not as just a collection of bytes of ASCII text, but we thought of it as a document, and we used the book metaphor to think about how you would take a piece of source code and actually publish it as a book. And if you get the book that Aaron and I wrote, you'll find within the book, in the middle, is a book within a book that shows the a implementation of Joe Weizenbaum's, a new implementation of Joe Weizenbaum's ELIZA program, using some of the ideas that we had for actually publishing source code as a book. It includes various indices, various graphical representations. It includes the history of the code and a rogues gallery set of pictures of the people who are involved in it, and various graphical abstractions, et cetera, et cetera. And this was work. My career has been characterized by a lot of dilettantism and also by interruptions for starting companies. And so this is something that we worked on for a while, and then we dropped. It has not been terribly influential, although in modern code development environments you do see much more use of color and typography than when we did this. On the other hand, the use of high-level visual abstractions to look at large bodies of code to understand what's going on, as far as I can tell, has been pretty much a failure. And I gave a keynote address at a software visualization conference in Brighton in September, in which I basically said the field of software visualization has failed. It was not very popular. But, you know, we never, no one ever came up and gave counter arguments. I think some people, I mean, the people who talked to me said, well, that was very challenging and that was very controversial, et cetera. And no one really engaged. I mean, I think in terms of software visualization for student use, there are numbers of people who build animations of little programs, but I think most computer science classes don't use it. I mean, so even that has not been, I mean, I think everybody should look at animations of every program they're running in order to understand them, and that is not the case, at least at the University of Toronto. Maybe it's different at Stanford. And certainly in terms of building and understanding large software systems, and when Aaron and I met at through this DARPA connection, well, actually, he and I had met earlier at, I think, SIGGRAPH 80 or 81 or something like that. But the DARPA, what DARPA was interested in this meeting they held at Key West was how do we help understand million lines programs. They couldn't even comprehend at that point that what Vista would be 60 million lines of code or 80 million lines of code. And so I believe firmly that visualization is important to this aspect of software engineering, and we just have not really come to grips with this at all. One of my dreams has long been, I mean, there's a discipline called medical illustration. Toronto has a department of medical illustration that's very good, small department. They take maybe 8 students a year, 10 students a year for a master's program. There's maybe a half dozen such programs in North America. I think there should be departments of software illustration to train people with computer science background and graphic design and animation and cinematography to help us use visual media to better deal with the abstractions of computer science or logic or mathematics or whatever. And I don't think we've done that. Yes?
One quick one. I'm curious, have you thought about how to apply your work, which has been done for people with disabilities, to cases where people don't have those disabilities as a method of augmenting, their experience of things?
Not directly, but we are looking at what are the needs of senior citizens, where a senior citizen might not directly have a cognitive disability yet, but we're trying to enhance their ability to use technology and possibly then make it easier for them to use technology when it can provide cognitive assistance later in life. And this has been very challenging. In fact, I have a student named Mike Massimi who tried to do participatory design with senior citizens for cell phone software. And paradoxically, much to our surprise, we thought that would be easier than Mike Wu's work with people with amnesia. And on the contrary, it was much harder. The Amnesics were a wonderful population because they were all very smart, highly motivated. Most of them had to give up their careers. And in a sense, they had more uniformity in their needs. So even though they had this incredibly severe impairment, memory impairment, they were perhaps one of your ideal design teams. And Mike is now, I think, in week 16 or 17 with this new design population. Mike Massimi worked with 5 older women, ages 55 to 85, and it was very, very difficult for him because they all had very different perspectives, very different goals. There was a lot of confounding issues. Every one of these ladies, I mean, there were some cognitive issues they were concerned about and technology issues, but one of them had poor vision. One was very hard of hearing. One had hand tremors, et cetera, et cetera. So there's a lot of interactions between physical and sensory and motor disabilities and cognitive disabilities. So it was a very challenging population to work with. So I'm not sure I answered your question, but it was something else I wanted to say. So,
Thank you.
For information on other online Stanford seminars and courses, please visit study.stanford.edu.
The preceding program is copyrighted by Stanford University. Please visit us at stanford.edu.